Hi everyone, in this video we are going to discuss polar molecules. So up until this point we've discussed what electronegativity is, we know what it means for an atom to be electronegative, we know what it means for an electronegative to be in a bond, so we can either have a polar bond or a non-polar bond, all of which we're talking about covalent bonds obviously. And now what we're going to do is talk about what happens when you have a polar bond in a molecule, or if you have a non-polar bond in a molecule. So it's a way to bring all of these topics together into one final piece. But before I go any further, I want to make sure when I'm saying polar molecule, you're thinking what I want you to be thinking. So let's get a definition out here first. So a polar molecule has two very important components, and you have to have both. So very simply speaking, it is a molecule with at least one, okay, at least one, super important, at least one polar bond. And so that's the first part of it. The second part of it is that it has the correct geometry. So what you should be thinking right now is that if you do not remember how to draw these molecules in three-dimensional space, so what they actually look like, then you need to review those videos, or you need to go back and practice that, because if you can't draw the correct geometry, you have no shot at determining whether or not a molecule is polar, okay? So they're very, very important, so make sure you review that. Now the opposite of a polar molecule would obviously be a nonpolar molecule. And so a nonpolar molecule is a molecule with no polar bonds, or, okay, so that's one example, or a molecule with polar bonds that cancel each other out. So what you should hear right here, or what you should see right here, is that it can be a little bit difficult to determine whether or not you have a polar molecule. Because in order to have a polar molecule, you have to have at least one polar bond, and you have to have the correct geometry. But if you have a polar bond, that doesn't necessarily mean you're a polar molecule. You can be a non-polar molecule if you have a polar bond, as long as the polar bonds cancel each other out. The easiest one to determine is if you have no polar bonds, then you know for sure you have a non-polar molecule. So the best way to actually look at this is if we do a couple examples. So let's start off with water, since that's what this entire module is about. So let's look at H2O here. First thing we want to do, you absolutely have to draw out its correct structure. So we know it's bent, it has an angle of less than 109.5 degrees. So now what we're going to do is label our most electronegative atom. It's oxygen, for sure. Oxygen is definitely more electronegative than hydrogen. Recall that oxygen is your second most electronegative atom. So now what we have to do is see if we can draw a line to separate these charges. Because we know if we have a negative, a partial negative here, and a partial positive there, that bond is definitely considered a polar covalent bond. So we've already identified that it has the polar covalent bond. That's the first part of it. Now we're trying to figure out if it has the correct geometry. Can we draw that line? Can we draw the line to physically separate the positive and negative charge? And we absolutely can do that with water. We see that this side right here, the top side is negative, the bottom side has all the positive charges. I can clearly separate negative from positive. This is considered a polar molecule. Okay, easily can separate positive from negative. Example 2, let's look at carbon monoxide. So hopefully you recall how to draw this weird structure. It is a little odd for a Lewis structure, I'll give you that. So now what we have to do is determine the most electronegative atom. Is it carbon or is it oxygen? It's obviously oxygen. Oxygen's the second most electronegative atom, so we label it there. Now we say, this is my negative side. This is my positive side. Can I draw a line to separate the two? Absolutely. I can definitely separate my positive side from my negative side. So not only do I have a polar covalent bond, I'm just going to label it CB, a polar covalent bond, I also have a polar molecule. Okay, let's do another example. For the next example, I want to do carbon dioxide. So we have a carbon in the center, oxygen on the outside, same thing on this side. Okay, label your electronegative atom. It's oxygen again. So this is negative. My carbon's going to be positive. My other oxygen's going to be negative. So I see a negative here, a positive here, a negative here. Is there any way that I can draw that line to fully separate my positive and negative charges? And no, there's no way. I cannot draw that line any which way, not at any weird angle where I can fully say this is my negative side and this is my positive side. And right away, whenever you see negatives on opposite ends like this, so you you see one on this side and one on this side of a linear molecule, you should automatically be thinking, there's no way I can separate those charges. This is definitely a non-polar molecule. And we're going to look at one more example, which is N2, so nitrogen, diatomic nitrogen. Okay, what I'm looking at here is a non-polar bond. It's a non-polar bond. My nitrogens are the exact same element, which means neither one of them is more electronegative than the other. I cannot put in this or this. That would just be absolutely bogus. There's no way you could do that. There's no way I can label that, which means there's no way I can separate my molecule into two different poles, a positive side and negative side. So N2 is definitely a non-polar molecule. Okay, so I want to give you one more question or give you one more example. I want you to actually try it. Please investigate ammonia. The first question I have, does it have polar bonds? Yes or no? Go. Did you get an answer? Hopefully you did. The first thing you have to do in order to answer this question is you must draw out your structure in the proper 3D geometry, okay? So when you do this correctly, you should end up with ammonia in a trigonal pyramidal structure. So now in order to determine if there's polar bonds, the first thing you do is identify your most electronegative atom. So we're looking at nitrogen or hydrogen. Nitrogen is tied in third place with chlorine for the third most electronegative atom, so this is definitely going to be your negative, and all of your hydrogens are definitely going to be positive. Once you've done that, you can very easily identify if there's a polar bond. So you just look at the bond and say, are they both positive? Are they both negative? And in this case, one's negative, one's positive. We definitely have polar covalent bonds. The answer is yes. So now my question is this a polar molecule? Go. Did you get an answer? Hopefully you did, and let's look at this again. Let me remove my yes and my arrow from the last question. Is it a polar molecule? Can you draw a line to somehow separate the negative side and the positive side? Yes, absolutely. Ammonia is definitely a polar molecule with polar bonds. All right, next one. Methane, Ch4. First things first, are there any polar bonds in methane? Go. Did you get an answer? Hopefully you did, and just like before, the first thing you have to do is draw out your structure. So if you draw out methane properly, if you remember to use your stick and wedge, hopefully you do, but that's okay if you didn't, we would see that methane definitely has a tetrahedral geometry. So after you draw this out, you identify your most electronegative atom. And carbon is actually slightly more negative than hydrogen is, so we draw in our partial positives and partial negatives here. And all we have to do to answer this question is look at the bond. Is there a negative on one side and a positive on the other? Yes, definitely. Do we have polar bonds? Yes, absolutely. So now here's the kicker question, the real one. Is it a polar molecule? Go. Did you get an answer? Hopefully you did, but if you didn't, that's okay. All you had to do was look at these charges that you've already assigned for the previous question. So look at your positives and look at your negatives. And what you should be able to see is that you have a negative center, and then in every single direction, in 4 different places, you have positive coming out of it. There is no way with a negative center and positives all around it that you can split that molecule in half, okay? So be wary. Tetrahedral molecules are classically known for having polar bonds, but being a non-polar molecule. So is it a polar molecule? Absolutely not. It is a non-polar molecule, but it has, actually, let me write molecule, with polar bonds. Okay, so these are the trickiest ones when they have polar bonds, but they're non-polar molecules. Always just remember the trick. Can I separate it? Can I put positive on one side, negative on the other? I'm going to leave you with that. Take care of yourself. Drink lots and lots of water.